Good day, students. You're welcome once again to my channel. Today we shall be looking at indices. In mathematics, what is indices? Indices is the plural form for index. Index is singular, indices is plural. It simply means power. So we shall be looking at some of the laws of indices. Laws of indices. Follow me closely. Remember that in my channel I make mathematics simple. So we should be looking at the first law, which is the multiplication law. The multiplication law. What does the multiplication law say? It says if you are given a certain number a raised to a certain power x multiplied by same a raised to another index y, this should give me a to the power of x plus y. Now please look at this very well. Because they are same base, a times a, we'll just add their powers x plus y. I'm going to show you proof. For example, if I am given 2 to the power of 3 multiplied by 2 to the power of 2. Let's do this. 2 to the power of 3 means what? 2 times 2 times 2. That's 2 in 3 places. Then we have multiplied by what? 2 raised to the power of 2 means 2 times 2. Now, how many of these 2's do you have? 1, 2, 3, 4, 5. So it's 2 raised to the power of 5. I'm not interested about what 2 raised to the power of 5 will give us. Let's apply it to this law. Let's see if this law will give us 2 raised to the power of 5. From the law of indices, 2 to the power of 3 times 2 to the power of 2 should give me what? Because they are same 2, I'll just pick one of the 2 and I'll add their powers. 3 plus 2, which is 2 to the power of 3 plus 2 is what? 5. So you can see that this is the same as this. So we've succeeded in proving the first law to be correct. So the first law, the multiplication law, is correct. A raised to the power of x multiplied by a raised to the power of y. I'll just pick one of the a and I'll add their powers. Our second law is the division law. Remember, your multiplication law is this, while your division law says a raised to the power of x divided by a raised to the power of y will be equal to a raised to the power of x minus y. This is the division law. Look at the difference between the division law and the multiplication law. For the multiplication law, when it is multiplying, we are adding the index. For division law, when you are dividing, you are subtracting the index. So let's also show a proof for it. An example. If I am given, let me still repeat 2. 2 raised to the power of 4 divided by 2 raised to the power of 3. Now let's show this. 2 raised to the power of 4 is what? 2 times 2 times 2 times 2. That's 2 in 4 places. Divided by 2 raised to the power of 3 is what? 2 times 2 times 2. So let's cancel out this 2. We cancel this 2. This 2, we cancel this 2. And this 2, we cancel this 2. I am left with just a single 2. So this is 2 raised to the power of 1, or written as 2. Now let's see if I apply it to the division law, if I'm going to get the same thing. Let's apply it to the division law. 2 raised to the power of 4 divided by 2 raised to the power of 3. I know it should give me 2 raised to the power of what? 4 minus 3 by the division law, by this rule. 2 raised to the power of 4 minus 3 is what? 1. So this is the same as this. So we've succeeded in proving the division law. Number 3 is the product law. What does the product law say? It says if I'm giving a raised to a certain index and they are raised to another index, This is the same as writing a raised to the power of x times y. This dot here means times place. So it's a raised to the power of xy. If I want to remove that dot, I can write it as a raised to the power of xy. The product law says if I am giving a to a certain index and it is raised to another index, all I have to do is just multiply the two index. The difference between the product law and the multiplication law is that you are having a, this one is just a raised to the power of index raised to power of another index, but for multiplication is a raised to the power of index multiplied by a raised to the power of the other index. So understand the difference. Let's do an example. If I am given 2 raised to the power of 2 and it is now raised to the power of 3, let's apply our product law. The product law says I'll just take 2 raised to the power of what? 2 times 3, which will give me 2 raised to the power of 2 times 3 is what? 6. Now, let's apply it and see how it's supposed to be. 2 raised to the power of 2 is 2 times 2. This is 2 raised to the power of 2, which is this. Now, this is raised to the power of 3, means I'm going to repeat this process 3 times. That's times 2 times 2 times 2 times 2. So this is 2 raised to the power of 3, because this is 2 raised to the power of 2, 2 raised to the power of 2, 2 raised to the power of 2, 3 places. So let's count how many 2 we have. 1, 2, 3, 4, 5, 6. So this is 2 raised to the power of 6. You can punch your calculator 2 raised to the power of 6 and see what it's going to give you. I'll say about 64. If you do this, you still get 64. So I've proved our product power to be correct. Now the fourth one is the product power law. This one is the product law, product power. Now for the product power law, I'm having two items, x, y, raised to a certain index, let's say a. Okay, let me be consistent and use my a inside the bracket. Maybe I'm having a, b. AB is a product. They are raised to a certain power x. The product power says this power is going to multiply everything here. So it's the same as a to the power of x times b raised to the power x. That is the product power law. If, for example, I am given 2, let's say 2x squared. This is an example. By the product law, it says I must square here and square here. So I must square 2 squared multiplied by x squared. So this is the same as saying 2 squared is what? 4x squared. Now this is what the product law is telling you. That when you multiply a certain product and all are in brackets with a certain index, to open up the brackets, this index must be reflected in each of the items that make up the product. That is the product power law. The fifth law is the zero index. The zero index law. What does the zero index law state? The zero index law states that any number raised to power 0 must give me 1. Anything at all that is raised to an index of 0 will give me 1. Let's see an example. If I am given 2 raised to power 3 divided by 2 raised to power 3. Now remember, let's apply our division rule here. 2 raised to power 3, because these two are the same, 2 is the same as what? 3 minus what? 3. And this will give me 2 raised to power 0. Now I want to see if 2 raised to power 0 will give me 1. Let's expand this one. 2 raised to power 3 is what? 2 times 2 times 2. All over 2 raised to power 3. 2 times 2 times 2. This, we cancel this. this we cancel this, and this we cancel this. I am left with what? 1. So I've proved that 2 raised to the power 0 is 1, which is our 0 index law. So any number given to you that's raised to a 0 index, it must give you 1. Now let's see number 6. Number 6 is the negative index. Negative index law. The negative index law says that a raised to a negative index, let's say -1, or let me even use -2. Once you have a raised to a negative index, let me be consistent, is the same as writing 1 all over a raised to power x. If I want to throw away the negative sign, I just introduce 1 all over. The negative has gone. A raised to power x. I'll show you an example. If I am given 2 raised to power 3 divided by 2 raised to power 5. Now, if I use our division rule, this should give me what? 2 raised to power 3 minus 5, which is the same as saying what? 2 raised to power 3 minus 5 is what? -2. So by negative index, by this index, it should give me what? 1 all over 2 raised to power 2. So now I've shown this. So let's do this. 2 raised to power 3 is what? 2 times 2 times 2. All over 2 raised to power 5 is what? 2 times 2 times 2 times 2 times 2. That's 2 in 5 places. This 2, we cancel this 2. This, we cancel this. This, we cancel this. I am left with what in the numerator? Just 1 all over. What do I have in the denominator? How many 2? 1, 2. That's 2 raised to power 2. So I've shown that this, by our division law, gave me this, and by negative index is 1 all over 2 raised to power 2. So we've proved this. When you have a negative index, is 1 all over. Take note of that properly, please. Law is the roots power. Now the root power says if I am giving a raised to power half, is the same as saying the square root of a. Or if it is a raised to power 1 over 3, it is the same as saying the cube root of a. This is the root power. For example, if I am given 9 raised to power half, 9 raised to power half is the same thing as square root of what? 9. Square root of 9 is what? 3. So the root power says if I'm given a number raised to a root, it is just the square root of a. Now the 8th rule also follows after the 7th rule. The 8th rule is the fractional index. The fractional index rule. Now, the fractional index says it just follows similarly as this. This time, our root is not just 1 over something. It is now a number over another number. If I am given a raised to the power of x over y, the rule says that this y becomes my root. That is the white root of a raised to the power x. Example, if I am given let me use 16 raised to the power of 3 over 4. It is a fractional index rule. I will just apply it. It's the same as saying the 4th root, because this 4 is under, it is the root. 4th root of what? 16 raised to the power 3. That is how you represent it. You can go further and simplify this one. 4th root of 16 is 2. 2 raised to the power of 3 will give you 8. So that is just what this explains. So take note of your 8 rules of indices. We are going to apply them in solving some questions now. Example 1. They said evaluate 16 over 81 raised to power of 3 over 4. Our solution. This is what? This is a fractional index. Remember your rule of fractional index. What does the rule of fractional index state? It says the denominator becomes the root, means fourth root, because the denominator here is 4. The fourth root of what? 16 over 81 raised to the power of what? 3. You can decide to put your power outside. Let me show you how to write it properly. This is the same as doing this. Raised to the power of 3. So this 3 comes the power. So let's evaluate this. The fourth root of 16, fourth root of 81. The fourth root of 16 means what do you multiply by itself 4 times to give you 16? My answer will be 2. What do you multiply by itself 4 times to give you 81? My answer will be what? 3. Because 3 times 3 is 9 times 3, 27 times 3, 81. Then I'm raising it to the power of what? 3. You apply your power rule. And because I'm having the division here, 2 numbers, this will take this will take this. So 2 raised to power 3. This is the same as writing 2 raised to power 3 over 3 raised to power 3. 2 raised to power 3 is what? 2 times 2 times 2, which is 8, all over 3 times 3 times 3, which is 27. So we succeeded in simplifying this to give us 8 over 27. That is the solution to that. Let's take another example quickly. 2a squared times 4a cubed. Alright, let's see the solution to this. I'm giving 2a squared times 4a cubed. Let me rearrange this and bring the numbers together, then our unknowns together. I'm having 2 multiplied by, the other number here is what? 4. Then multiply by, let's take the unknown, a squared times a cubed. Now I did this. Why am I doing this? Because this becomes my what? Multiplication law. Remember the first law we did, multiplication law. So this will give me 2 times 4 is what? 8. By multiplication law, if I pick one of the a, I'll now add what? The powers, 2 plus 3. So this will give me 8a raised to power of 2 plus 3 is what? 5. Succeeded in doing that. Example 3. Evaluate four p q raised to power 3 divided by 2p squared q squared. Alright, let's see what this is going to give us. Solution. I am giving what? 4p q3 all over what? 2p squared q squared. Now let's take the numbers first. That is 4 over 2 multiplied by, let's come to our p. I'm having p. I'll pick one of the p because it's division. This is p raised to power 1. Remember, because no power, it means it's 1. P raised to power 1 divided by p raised to power 2. By our division law, we said if I'm picking one of the p, I'll subtract the power 1 minus 2. Then I come to my q. I pick one of the q. What do I do to the powers? Because it's division. This is division. I will be doing what? 3 minus 2. You can put them in brackets to show you know what you're doing. 4 divided by 2 is what? 2. Then p 1 minus 2 is what? Minus 1. Then q 3 minus 2 is what? 1. I can simplify this further. My negative index rule. Remember your negative index rule says what? I have this 2. Because it is negative index, I'll write it as what? 1 over p multiplied by q. So you can write it as 2 times 1 is 2 times 2 is 2q all over what? P. So we've succeeded in doing that. Please understand your steps very well. It is very easy. Indices is easy, and it comes out every year in your WAEC examination. All right, we'll take further example. 4. Evaluate 3a squared times 5a raised to the power of minus 2. All right, now let's do this. Solution. We are given 3a squared multiplied by, now look at your question very well. Product, but we are having a negative index. Remember that if you have a negative index, you remove the negative sign, you change it to 1 all over what you have, 5a raised to the power. Now I've removed the minus, now it becomes what? 2. Now I'll still apply my product rule. Okay, let's multiply out. 3a squared times 1 is 3a squared all over. Now this squared doesn't affect only one items because it's in brackets. Product rule. Remember your product rule. So it's the same as writing this as what? 5 squared a squared. Take note, please. This square affects the two products inside here. 5 squared a squared. Now I can simplify that further. Now you can decide to do product rule, or you cancel out directly because a squared can cancel a squared. But let's also apply the product rule. This is 3 all over 5 squared is what? 25. Multiplied by, because this is division, I will just pick one of the a. What's the power here? 2 minus, what's the power here? 2. So this will give me 3 over 25 multiplied by a raised to the power. 2 minus 2 is what? 0. Any number to power of 0 is what? 1. So 3 over 25 times 1 will give me what? 3 over 25. Now that's the answer of that question. I'm sure that is clear enough. We'll take one final example. 5. Evaluate 2 to the power of x equal to 16. Now look at this question very well. I want to introduce you into something that WAEC does very well. Now they'll just give you this question and say you should look for x. Solution. You can see that this doesn't follow any of our rules of indices that we did, but I'm going to explain something to you. 2 to the power of x equal to 16. I can rewrite it as, I can rewrite this as 2 to the power of x equal to 16. Because I'm having 2 raised to the power x, can I represent 16 as a base of 2? Yes, I can represent 16 as a base of 2. 16 is the same as 2 raised to the power 4. If 2 to the power of x is equal to 2 to the power of 4, this 2 can cancel this 2. So I'll be having my x to be equal to what? 4. Now, they only just gave you this to deceive you, but just convert your 16 to a base of 2. That is what we did here. Let's take one other example on this. Example 6. Evaluate 3 raised to the power x equal to 27. All right, now I'm given this 3 raised to the power x equal to 27. What do I do? The same way we did this one, 3 raised to the power x, I'll represent 27 in a base of 3. My 27 is the same as 3 raised to the power what? 3, because 3 times 3 times 3 will give me 27. So that this will cancel this. I'll be having my x to be equal to 3. Alright, I'm sure this is clear enough. Alright, let's still do one more example and let me make it a bit harder so that you understand properly. Example 7. It says evaluate 27 raised to the power x plus 2 equal to 9 raised to the power 2x. Alright, now let's solve this. Solution. Now look at this properly. What base can I raise 27 to and 9 to so that I'll be having the same basis for two of them? 27, I cannot raise 9 to a base. I cannot raise 27 to a base of 9, but I can simplify 9 and simplify 27 to a common base, which is 3. So what do I do here? 27 is what? 3 raised to power 3. Don't forget it is also raised to power what? X plus 2. Don't forget that. Equal to 9 is what? 3 raised to power 2. Don't forget it is also raised to power what? 2x. Now you apply your product power rule here. So this is the same as saying 3. We said when you are having a product power rule, you multiply the product. So I pick the 3, I multiply this by this. 3 times x is 3x plus 3 times 2 is what? 6. Equal to, I multiply the product, 3 raised to power 2 times 2x is what? 4x. Now my bases are now the same, so the bases can cancel out. So I'll now be having 3x plus 6 equal to 4x. Now in your equation, when you were doing your linear equation, they told you collect like terms. I'll just take this one to this side. So I'll leave only 6 here to be equal to 4x. Remember that here is the same as positive 3x. When it's crossing a sign of equality, it becomes negative 3x. So my 6 is equal to 4x minus 3x is 1x, which is the same as x. So my x is equal to 6. So we succeeded in finding x in this question. So students, I'm sure with this you are able to understand indices and solve any question in indices. If you have any problem, just write on the comment section and I will respond to you. If you want a video, I will do a further video also to explain to you. For my WAEC student, please endeavor to solve every question in your past question and answers on indices, and I'm sure you'll be able to solve all. I celebrate you.